Thank you. I just realized I was on mute there. Can you hear me okay?
Yes, sound great.
Good. Good. All right. Um, so I'm trying to pull up a point cloud file to show everybody kind of the point clouds that we create when this is done. It's not the software doesn't seem to be cooperating, so hopefully it's ready to go by the time I get to that point. But um, so agenda, I just hope to cover. I'll introduce myself, do a little safety topic, give you just a real quick background on CDG and who we are. Kind of talking about two things here. One is the kind of legacy facility design and how what process we go through as engineers when we do that, when we're doing design at existing facilities. Use a Red Rock dam project that we had as an example. Kind of go over some lessons learned that we had in that, and then some other project examples. And then kind of what we're doing to work in a decentralized kind of work environment with the advent of COVID and using these consulting teams that are spread around the country. How are we getting that work done, and some of the tools we use, and just some of the lessons that I've learned along the way. So safety topic today, since we are talking about existing facilities, especially a dam, I like to good safety topics that when you do go out in the field, you always want to make sure you do a job assessment before you get out there. So before you're going on site, you definitely want to have a meeting with your team or the client and talk about what work you're going to be doing and prepare for that work before you go on site. So I'm an electrical engineer. So when I go on site, if we're going to be opening up cabinets, we'll coordinate with an electrician, but we'll make sure we have the right PPE, the right gloves, right FR, fire rated clothing for that kind of work. Any kind of arc flash protection we might need, metering equipment, flashlights, voltage rated equipment, that kind of thing. We always want to do a job hazard assessment before you go on site. Typically, you see that for contractors, but we also try to incorporate that as engineers into our field work because we do go to a lot of these legacy facilities quite often. Again, my name is Pat McAvoy. I manage our electrical engineering department at CDG. I've been there for 14 years, been managing the department for about 2 years. And my specialties personally, I do a lot of power engineering. Started as a project engineer at CDG and moved into project management, and now manage our group. Doing a lot of retrofit design, so legacy kind of facility design. CDG does not do a ton of greenfield design. We're doing more, I guess, brownfield, doing work at existing plants on facilities. And then I've got a lot of background in arc flash and SKM modeling. CDG is headquartered in St. Louis. We have offices in Wyoming, Illinois, and North Carolina. Started about 30 years ago this year, so we actually are celebrating our 30th anniversary come April. But full service firm. Um, we do a lot of work in existing spaces, so our market segments are power utilities, federal work, heavy industrial type facilities. So places that most people off the beaten path don't go to check out. Um, so legacy facility design. So project I'm going to talk about specifically is a Red Rock Dam project we had. It was involved electrical upgrades to the facility. So they had an original electrical system and an elevator. Part of the scope was to update that electrical system. They actually had an arc flash incident at an existing junction box on supporting some raceways. So they had an arc flash incident with some old wiring that they're not entirely sure how it started, but likely was it's an exposed junction box or exposed to the elements. So likely got moisture in there over time and eventually could have shorted out or caused an arcing fault of some sort. So the electrical system was dated. They still have original disconnects and panels and that kind of thing. So it was upgrading a lot of that, putting in new lighting. Then while they're doing that, they're going to update some mechanical systems. So update the elevator, put in new sump pumps, some new controls for the sluice gates, that sort of thing. So Red Rock Dam has been around for about 50 years. It was opened in 1969. And an interesting tidbit I learned from Wikipedia actually was that the lake was supposed to take 3 years to fill up, and they actually filled it in 5 days because they had a flood event. So I thought that was pretty interesting. So when we're doing legacy facility design, what are some of the obstacles that we run into as engineers? Biggest one is usually standards have changed. So if it's the NEC, National Electrical Code, the International Building Code, the NFPA, National Fire Protection Agency, a lot of those codes are pretty different now from 1969. So they may not have existed back then. They may not have had a certain standard back then. So when we go to do our design, we have to design towards those new standards. Also, the client standards might have changed. So um, the cores change, standards are constantly changing. So they have new requirements that we have to take into account when we do our design. So big obstacle for us is the standards that have changed. Equipment age, that's pretty obvious, but uh, equipment at these facilities has been around for a while, or the building itself. So you're going to have, especially in the dam, you're going to have moisture leaking in the gallery areas. You're going to have pipes that have rusted or have corroded. You're going to have steel that might be rusting, or rebar and concrete that is kind of losing its integrity. Um, you're gonna have to tie new equipment to old equipment, or new steel to old steel. So you got to get pretty accurate about how you do that. So you might be, if you're framing something new, you're gonna have new steel framing that's got to somehow tie to the existing structure. Um, One issue we always run into when we're doing legacy installations is whenever we do something underground, it's always a big area we got to watch out for. So electrical, we run a lot of stuff underground. If they have a duct bank, they want to put in some medium voltage cable, they want to run that underground. They might directionally bore that. They might trench it and do it that way. You learn pretty quick when you make the mistake the first time, not to repeat it again. So underground stuff is always you always want to scan it, um, whether it's ground penetration radar or doing a survey, getting existing drawings, trying to find something that tells you what's underground before you do any kind of digging. Um, it's always an easy way to run into construction issues. Another obstacle is drawings. So at a place that's 50 years old, like the Red Rock Dam, you're either going to have drawings that are outdated. A lot of times you're going to have various sets of drawings. You're going to have small one-off projects that have been done, but they may not have been incorporated to the entire drawing system of the facility. So you might have some stuff or some areas that have new drawings or updated drawings, and some that's just the legacy drawings from the plant years ago. A lot of times, maintenance guys are busy, so maybe they haven't had a chance to update the drawings or mark it up. And also, sometimes drawings are just non-existent. If it's an old enough place, say they stored them away somewhere, they didn't have the ability to have electronic versions. They didn't scan it, and they just lost track of those drawings. Maybe they got damaged. So how do we do design in these kind of facilities where we may not have good information, um, or the facility is just you know old and well aged, and also just field time and access. You know, since these are existing facilities, it is really important that you get on site and go look at them. Um, and getting access to some of these places can be difficult. This side, Red Rock Dam is in good shape, but there's other places that I've been for generally more private clients that maybe they haven't maintained anything. They could have flooded areas in their facilities in the basements, but they still have equipment down there that's operating. I've seen that before. So these are some of the obstacles that we run into when we're doing our design. So um, how do we mitigate some of these obstacles? So first one on standards is definitely to know your standards. So have your codes changed. So in this facility, they needed to replace. They wanted to upgrade the elevator. So the elevator code has changed quite a bit from when this elevator was first installed. So the elevator code is significantly different. There's now there's the NFPA 72. There's also elevator recall systems, and I'll talk a little bit more in detail about what they've what they learned when they went to go put this thing in. Um, NFPA has a lot more standards than when this building facility was built. Um, but having a really good understanding of your codes and your standards that you want to have designed to, and figuring that out at the beginning, goes a long way in refining the engineering scope. So that's how you avoid change orders from folks like me. Um, so when you're able to dig into that and kind of know those nuances before you get started on design, that definitely saves you a lot of headache. Equipment age, so definitely mechanical systems. They're gonna break down, especially over the course of 50 years. They're gonna break down. So the sump pumps might get clogged. The piping for those sump pumps um, might corrode. HVAC systems are gonna be. There's definitely more efficient systems now than what was first put in. The lighting, a lot of the lighting here was, I don't know if it was original, but the fixtures might have been original, but the luminaires, I guess you should say, were original, but the bulbs were clearly updated and replaced. So you can put in more efficient lighting. So how do we capture, these kind of existing conditions? So if this stuff has changed, but it's not documented, it's all age, how do we get a hold of that, get that understood? So one of the main things I wanted to talk about was scanning and the benefits of scanning. So for this project, we did a LIDAR scan using a Faro scanner. It's a tripod mounted scanner that just does a 360 kind of scan at each spot wherever you place it. So you can see this is kind of the inside of the whole gallery and the stairwells and above ground. And so what the scanning allows us to do is to tie new systems into existing. It is very good for that. So some of these facilities we go to, not just Red Rock, but other places, they've got steel that's been there since the facility was built 40, 50 years ago. Modification stuff's been added onto that. Steel's maybe been modified. So how do you get a good current picture of that? So we always can. This can get down to the millimeter level of accuracy. Gives you a good comprehensive look at the physical data. So you can kind of see here. You can see the whole layout of the dam on the inside. So you can see the stairwells, the the grout gallery, the I'm blanking on the gallery here, but this is where all the valving is, elevator shaft, and where the equipment areas, even the roadway, parts of the roadway got picked up. This is actually looking at there's a catwalk that goes underneath the roadway with control equipment for tanner gates. So you can actually see the spillway and the tanner gates that got picked up by the scan in that area. It's very good for catching interferences. So this is big for when we're doing large equipment installations, uh, for finding interferences with existing mechanical and electrical systems and steel. So it's a great way if you have a large piece of equipment that's going into a space. Doing the scan really helps you pick up those interferences and account for them, and scope them out for your contractors well in advance, rather than having to figure this out on the fly in the field. It brings the field to the office. So at each point uh, where we did our scan, it does a 360 photo. So in the software, you're able to go back into those photos and you can look around just like you were there standing, and see equipment. So if it really cuts down on our field time, so we can usually go out there once and get the data we need, and then we can avoid those second or third trips. We can go back and see this. We can take measurements. The software has the ability to measure this. We will take this into CAD software like Revit or AutoCAD and actually do our design in this virtual environment, and it really helps us get a more accurate picture of our design. So 3D design software we're using. What I list here is just stuff that we might have used for this project specifically. But so Autodesk, we're using that whole suite of software. So that's Revit, Recap, Navisworks. I know the core uses MicroStation generally. SolidWorks is another one. Dialux, which is the software used for this, is a software used for lighting design, and it shows it does good 3D visualizations of the lighting, so it kind of helps people that may not want to get into the nuances of foot candle calcs and that kind of thing that electrical engineers get into. It will show them visually how the lighting will look, and it usually goes a long way for the non-EE folks. So this is just showing how that point cloud looks versus the drawings that we created for it, or some of the drawings that might have been there before. So this is actually a mirror image, but you can see our stairwell here is matching the stairwell on this side. So this is flipped 180 degrees, but you can see our gallery above kind of matches. So this is just kind of a schematic representation of what is physically there. So see if this point cloud has come up and is actually working. Looks like it is. So I just want to show real quick the software that we use for this kind of thing. So if I zoom out, and hopefully this doesn't crash the system, you can see this is the actual gallery itself, and the photos are these little bubbles, and they show the picture that was taken where the scan was taken. We'll see if that goes in the, it's thinking. While it's doing that, I can come back. So here's some screenshots from the actual scan that we did. So we use these as electrically, for our electrical design, we do a lot of, we call them like relocation or demolition or modification photos. So we'll show demo pictorially because we found this easier for a contractor to pick up. He can go stand in this space in the facility and actually look and see what we want to get done. So this middle picture is a point cloud scan of the stairwell. The D8 and A8 details are actually using 360 photo screenshots from our recap model. You can change the intensity so it picks up levels of detail a little bit better. I may not like that. So the point I want to get across is just the aid of a scan helps us. We pretty much use this on most projects where we are doing design in a facility because it doesn't cost us much, and it just provides that much more value to a project. So some of the just a little update on the Red Rock project. So what the project entailed was new electrical systems. So you can see in the photos above, they had legacy disconnects, transformers. It's all original conduit and wire. There's been some modifications to the system as they've had to replace or add new equipment, but they wanted to kind of update the electrical system so it, can last them for years to come. So they upgraded that. They replaced all the lighting with new LED lighting. So it's definitely more efficient. Should last significantly longer, have less frequent replacing of bulbs or fixtures. They replaced 2 of the sump pumps that were in the grout gallery. New elevator system. So the elevator was updated to new standards. So that was a big deal for them. So then where the project is now is still currently in construction. I think they're waiting a little bit apart. So I do want to thank Brian Radke and Matthew Fitzgerald from the Red Rock district office. They are the ones that are doing this installation themselves. CDG did the design. We did not have a contract to help with the construction support. So Matt and Brian have been handling that themselves. But so they were helpful in telling me kind of where things are at and what their lessons learned have been so far. So it's waiting on some parts of the Slew skate control system. Most everything else is done. They're going to get new panel boards. Um, Upgrade the new elevator upgrade is going to have new controls, new fire alarm, phone system. I mentioned the mechanical system, the mechanical room for the elevator, where the controls for the elevator are housed. That's got a new HVAC system, and we also updated their arc flash study. The two photos in the middle are from the software used for the lighting design. So these are 360, not 360. These are Dialux uh, photos. So that what we're showing here is the new lighting that we've put in. So you can add in the actual fixture you want to use, the location in the 3D space, and see the actual lighting, how it looks. And this will also put out full candle calcs and that kind of thing, but we use Dialux quite a bit these days. It's not like in the 360 photo, so I apologize for that. I thought it would be okay with the 360 photo, but doesn't seem to want to work. So some of the lessons learned that they had, I talked with them the other day about it. Directional boring in the levee. They had some points where where the frac stuff would kind of popped out or seeped out of the levee, so they were directionally boring some a new power feed, medium voltage power feed to the area. So that's kind of one of those underground issues. This kind of gets back to standards and how they've changed. We actually had a project at Lock 27 in the St. Louis district where they were putting in a new power system, and they had some poles that were mounted on the levee. And to do that work, they wanted to take out the poles and redo the electrical system, the main transformer to be it was a primary service, a 4160 volt service. They wanted to make a secondary service, so the utility on the transformer, and they would have a 40 volt service to the lock and dam in Lock 27. Well, so when they went to go take out the poles and put in a new underground feed, the levee folks at the Corps said, no, you're not, you can't do that. We're not going to let you put the poles back in the spots where you had them and all that. So it became a kind of um, a big deal because now we couldn't route our power where we thought we could. We couldn't put it on top of the levee at all. So we had to completely reroute it. But that's a new. I don't know if it's a hard line standard, but it was a, a new standard that we didn't think of, that we didn't expect that the levee folks would be that adamant about touching it at the time. So another lesson learned was in the grout gallery, the moisture. There is a lot of moisture in the grout gallery, so the fixtures we picked were not necessarily wet location, but they are a NEMA 4X design, but they may not be exactly perfectly for wet locations. And then we've got aluminum housing, so they're hoping that it'll last, but they mean the fixtures we picked may not be the best for that environment. Um, this next one, elevator mechanical equipment. So the elevator mechanical equipment is larger than originally anticipated. So this kind of gets back to standards and just taking existing equipment and putting into new equipment and putting it into existing spaces. So the mechanical systems for this elevator are significantly different than what we initially built. So the elevator scope was more of a design build scope. That was kind of carved off to an elevator contractor. So they would order the elevator equipment and they would put it in kind of in a design build. So we spec'd it all out. But the mechanical equipment that ended up showing up would not fit in the existing space. So they actually had to take out a wall. They'd expand the wall out and relocate the stairs in order to fit this mechanical equipment in. So that was a big one. That's why it's really important to understand your standards, but also try to get a really good idea of how equipment's changed when you go to put in new stuff in existing facilities. They added some heater and thermostats to the Tanner gate controls that were outside. That was at the request of the control equipment vendor. Um, Existing telephone conduit. That we added some cables for the phone system, mostly for the elevator, and the existing conduit that's along the top of the dam was just not large enough to accommodate the amount of cables we initially wanted to add, but we were able to pare down the amount of cables, take less spares, and fit it that way. One of the more interesting ones was the fire alarm system for the elevator. So the fire alarm system was designed towards the NFPA 72 uh, rather than the elevator recall design with an auto dialer to the main office. So what that meant is that the elevator recall system is actually a little more stringent than the NFPA 72 um, standard. So it required them to kind of rework how they did the fire alarm system, um, mainly meaning that they need to know the fire alarm system has to be intelligent enough that when they detect fire at a certain level, that the elevator does not open the doors to that level, that it avoids levels that are having um, a fire or a smoke event. So that was part of the big reason. And also this auto dialer goes to the main office. It does not, the system does not automatically call the fire department. It calls the county. So that's a little different thing that we kind of learned along the way. Last one is the sluice gate, or second to last one is the sluice gate controls. Going up here, so the sluice gate controls, that's what we're looking at here is this sluice gate. So it's actually a hydraulic system. So there's a piston in here that they actually had the mechanical system before was a wheel. You see that little wheel there? It actually uses friction, and as the piston moves up or down, they use that wheel to gauge how to determine the position of the gate. The issue is that over time, this little wheel loses its friction, so it slips and may not be able to show level as accurately as they were wanting. Additionally, there is no communications to this, so they have to go walk down there themselves, look at these. There's actually little tick marks on this uh, cylinder to verify where they're at. Um, so it was just kind of an outdated system. It just wasn't doing it the way they wanted to. So what we ended up doing is putting in a flow meter for the hydraulic fluid that goes in here. And what the flow meter is intended to do is to measure how much hydraulic fluid is passed through, and it uses that with a transmitter. And with that, you can tell the position of the piston based on that. So we put in a little controller. That controller would be able to communicate back to the office, and so they can actually read from that at the office what the position is, rather than having to go into the field and read off of each one of these. So the issue we ran into this was that the vendor actually supplied a flow meter that was not bi-directional, meaning it could move in one direction and tell you the position in that one direction, but when the piston moved back down, it was not able to tell you the position. So they had to get that replaced. Second thing, and this goes back to why it's important to verify when you have drawings, existing drawings, is that the drawings from this project, so the as-builts, the flow rate was actually 1.5 times higher than the as-builts. So Brian Racky said that when they went to turn this on, there was a high pitched squealing going through this flow meters. They was like, that's not good. So they took it apart. They realized that the flow rate was actually 1.5 times higher than what the as-builts initially said. So they got a appropriately sized flow meter, and then they're waiting on. I believe they're waiting on the controller, but they'll have a bidirectional flow meter with a larger one. And then it's just a prototype, so we're going to test it out first and see if it works. And then if that's all good, then they'll move towards replacing the system on all the other, I think it's 13 sluice gates. So last one was the modified HVAC. They moved the condensate line, so it went outside. I think we had to go into a floor drain, and then they actually had an exhaust fan. So when we have this HVAC, it's for the elevator control room. Um, they're using that to exhaust, so that's dumping heat into the remaining space, and so they're actually using a vacated conduit penetration to vent out the air from where the HVAC is dumping its heat to. So just some lessons learned from that project specifically. So Next, I wanted to show you, bummer about that scan, just some past projects where we've done scanning and actually incorporated into design drawings and um, larger projects that were full discipline. So they included mechanical, structural, civil, as well as electrical. So uh, this project that I'm showing is to put a new enclosure on top of a battery room. So this is inside a power plant. There's an existing, this is like a 40-year-old power plant. They have a battery room. So this is where they house their backup batteries for their control power, as well as uh, like DC lighting, emergency lighting, DC motors they use for starting their turbines, that kind of thing. So they needed to relocate their DC switchgear, DC equipment, which is this existing stuff down here. They wanted to put it in a building on top. So you can see the amount of so there's tray, there's piping, there's an existing exhaust duct that comes out of the battery room. So all that had to be relocated. So we can actually show our building. This is just for showing kind of existing versus new. We were able to really show well the amount of interferences they had to move, relocate, and come up with a plan for that. So all this tray that had to relocate, it's got existing cables in it that power a lot of important equipment. This is powering protection relaying, it's powering control uh, power systems for the DCS. So they had to be really they had to know for sure if they were relocated and come up with a good plan. So we're able to put this into a point cloud and reroute it in a way that is actually maintaining the the length of the cables. So they're not having to cut cables, terminate them in a box and all that. They're able to keep stuff running longer. So this is the end result on the right. So um, worked out pretty well for that. These other two are just examples of point clouds we create. The one on the left is made with a drone. That actually takes our conveyor that we designed for another plant, and we're able to show that um, in the point cloud we created with the drone, so they can see kind of where everything's going to be laid out, give us a good big picture view. One on the bottom is from a LIDAR scan, so it's just showing the size of the equipment that we're putting in an existing space. So we were able to relocate all of the piping that was going to hit this thing. And that's what these lighter colored pipes that are new, these are actually rerouted routes. So this piping used to go through this conveyor and now goes around it. Same with electrical systems, building steel. This conveyor needs supports all this new steel. We're able to show where that ties in and how to properly get that in. Last one is this is this existing facility is, I think, 45 years old. A lot of existing steel. They needed to add some new conveying to a new structure. So this is actually inside of a very large building. You can see this conveyor is going through an existing maintenance building. There's an elevator right here that we have to avoid, a service elevator. There's all sorts of tray and existing steel. Um, and this is the end result. So we were able to do it. Now, if it wasn't for scanning, this would have been a lot more money and a lot more time from a construction standpoint. So we were able to plan and help the contractor plan ahead as far as all the stuff they needed to move and relocate. Um, so the construction went fairly well for each. They did these in two phases. So they actually built this conveyor first with the whole structure, got that up and running, and then they did this second conveyor system. So just some other examples of why of the power of point clouds and scanning and why it's so useful for us, and some other tidbits on the design process we go through as engineers on these legacy facilities. So, and then decentralized design. So I don't have a whole lot to go through here. This will be pretty quick, but I know we're all kind of used to working remote at this point with COVID and everything. So I think a lot of people have a good system. This is just kind of some of the tidbits that we've learned along the way. This is just some of the tools and software we use. for our cost, for our budgeting, for our projects, we're using Deltek Vantage Point. It's a cloud-based system, so we can access all that online. So we can see our projects online rather than having a remote into our server. We can access it there. Tableau is really good for trending and data management and that kind of thing. Design collaboration. We're using a lot of Bluebeam Studio. So I have a project right now where we're projects in Phoenix. Um, the design team is spread out around. So I'm located in St. Louis. So we're in St. Louis. There's another designer that's in San Francisco. The project manager is in Atlanta, I believe. The project itself is in Texas. Um, there's some other people I'm forgetting, but we use Bluebeam Studio for these design packages. They upload their PDFs. We're able to review them all there in the same PDF file that's cloud based. So when we open up our Bluebeam program, we just log in and it goes to that PDF, that Bluebeam Studio session, and we're able to see all the current drawing packages and review and add comments. Everybody can see them in real time. Projectwise is obviously core. I think uses this quite a bit. That's pretty very good. One for document management. Well, I don't know if the core is using Revit a whole lot yet, but we use it pretty well and pretty extensively for private clients, and a lot of that is now cloud based. So it was BIM 360. I think it's being rebranded as Autodesk Cloud or Construction Cloud, something like that. It My point is that it is Revit software is an Autodesk product that so when we do our designs like that, those point cloud and structures that I was showing you about, we are doing those. We can do those in Revit, so we can have a decentralized team where maybe a structural engineers from another firm and they're doing their structural design and their model. We're doing our electrical design and mechanical design in a model that we own, but all those are synced to the cloud, so we all are looking at the same information. Um, Tough to do with point clouds. Point clouds are just too data heavy, so that's not necessarily a great use to do with a point cloud. Um, Construction collaboration software. So we've been historically using New Forma for ourselves for document management. Autodesk Docs and Collaboration is a new uh, tool from Autodesk. That's actually a good project management tool that we've been looking at. SharePoint, Procore, Projectwise. I think the core has their own auto RMS system. These are all really good collaboration tools for construction. And communication. This is all pretty obvious. I mean, we're on WebEx right now, right? CDG uses Teams primarily, just because we're based on Office 365. There's GoToMeeting, Zooms, plenty of others. Phone and email are still a communication tool, so I'm always preaching to our younger engineers that email is great. I still run in the habit of using email too often when I can just do it with a phone call. So I'm trying to press on that. Don't be afraid to call people still. It's okay to call, or rather than doing a Teams message or an email, you can pick up the phone and call them on their phones. Get a lot done that way. So just some of the tools and software we use. So some of the challenges that I've seen, clients and owners all are having the same tools and software. So we all use a variety of stuff. So we use CDG uses Teams and um, Autodesk products primarily. We also use MicroStation and that kind of thing. We don't necessarily use everything because it's too expensive. We don't use Procore because we're not really doing an exorbitant amount of construction management, so that kind of thing. But everybody kind of has their own tools and standard stuff. The core has their standard stuff that they want you to work in. So they have doctor checks and Projectwise and RMS. Other consultants have a variety of things. So some of the challenges I see is that everybody uses different things, right? So when you have a project team that is decentralized, when you have somebody from CDG and somebody from HDR and somebody from Bergman or some other consultant, you got to figure out a way to get you guys all in the same system, all using the same thing to help communication. So a lot of challenges that are software cost. So CDG is a small business. We're only maybe 85 people. Another company like an HDR or something like that, they're going to be thousands of people, right? So the tools that they can afford are a little different than the tools that CDG can maybe afford. Licensing. So say you standardize on a system, you say you're going to use Projectwise for a project, well, you got to make sure everybody has actual licensing capability to get everybody access to that. You got to worry about user accounts and logins and all that. CAD design, right? So example I'll talk about here in a second, Cedar Rapids, that was Projectwise and using MicroStation for CAD. But in the private world, when we're using a lot of Revit, you got to make sure everybody's on the same version, that everybody's got 2022 Revit or 2021 Revit. Otherwise, it's going to screw up the model for everyone. So it's really important to make sure that you're all on the same page in terms of software, and you do a lot of this planning beforehand before you get going into it. Cybersecurity. So everybody knows. I think cybersecurity is a big concern. Our insurance is going up for cybersecurity, just like I think everybody else's is. So I don't want to be too much of a dead horse there, but cybersecurity is you got to protect yourselves. You got to be really strong in your user accounts. Maintain good practices. I'll get to that in a second. File organization. So the decentralized team, if you've picked a system you're going to use for document management, you got to make sure you all have a good understanding of the file organization. So sometimes I'll see that consultant one wants to use this kind of file structure. It has this, they're just used to doing it one way. We're used to doing it another. The client's used to doing it a third way. So you got to make sure you're all on the same page. If you guys all call it different things, or if you structured it different ways, nobody's able to find anything, and runs into big problems. Two is, or next one is bandwidth. What I mean by that is just having the hardware and the setup to actually run your projects from a decentralized format. So you got to make sure your people on your team have enough internet capacity at their house to actually work on these files like that. If you're going to use a big system, like say you're using Revit and everybody's working in Revit, are you going to, if you got a small consultant on your team, so you got a WBE or MBE companies, maybe like 5 to 10 people, do they have a setup where they can actually handle that volume of data from a bandwidth standpoint? That's stuff that's usually a challenge that I see, is that it's hard for the little guys to kind of get up to the same level of um, system as the big guys. Time zones. I mean, we got this one project in that I was mentioning about. That's I think the project itself is in Texas, but everybody's kind of spread out. We got people in Phoenix setting up meetings for us at 4 o'clock in the afternoon, and I'm on St. Louis time, so that's at 6 o'clock. And then if I'm traveling to our Charlotte office, it's 7 o'clock around there. So you got to be cognizant of people's time zones and where's everybody at. If you're setting a meeting, you're in Mountain Time, and half your team's in East Coast time. You got to accommodate them. Then flexibility versus inflexibility. So one of the challenges that I see is that uh, we want to be more flexible by having a decentralized team, right? We want to be able to accommodate people in the cities that they live in, have all this talent that's kind of spread around the country, all work in the same project, but yet we want to be inflexible. We want to, cybersecurity is a big deal, so we want to be stronger in cybersecurity and have all of these tools at our disposal, but we also want to be flexible by having everybody decentralized. We got to, it's kind of a push-pull relationship there. So an example project where this worked well for us was Cedar Rapids. I should say FRM, not RM, Flood Resource Management. This was a project where CG was the prime. Our project entailed that Cedar Rapids project is divided into reaches. So we had reach one, flood wall and levee design, and then there's 3 pump stations we were designing. All in all, it's going into construction now. I believe construction is supposed to start on one of them this summer. But it's somewhere in the order of 60 to 70 million estimated construction cost. So CDG was the prime on that. HDR and Bergman were our subs, but um, we were working for the Corps. A lot of this work is being done in the city of Cedar Rapids, so there's city of Cedar Rapids personnel on it. Other stakeholders. So one of the pump stations is actually in an existing building, is the CRST building in Cedar Rapids. So we had to get with the building owners. The city of Cedar Rapids is also doing their own work for this levee system, and they have their own consultants. So we have to involve them in the design process. The project is located in Cedar Rapids. However, the people on the team, so the core folks are out of the Rock Island Arsenal. Um, CDG is located in St. Louis. HDR is people in Omaha and Minneapolis and Chicago. Bergman's primarily in Rochester. So we have these people spread out all over the country in different time zones, all working on the same project. And this is all during COVID, mind you. So this happened, design started, I think, in 2019. We had to be done by May of 2020. So we were kind of in the middle of finishing up, and then bam, we all had to go home and work remotely. And we kept it going. So it actually worked well because we had a good team and a good system. So we had all the documentation was held in Projectwise, and that was really well structured as through HDR system. They did a really good job on that. Quality was all kept tabs on through Dr. Checks. We communicated primarily through WebEx. But it shows you the power of the decentralized design can work. You just got to get everybody moving in the same direction. So some of the recommendations I had, I'm getting close to time here. I like cloud and web-based software that everybody can use. Cloud-based, I think, is better because that way you don't have to worry about having this residing in a server that you got to remote into and get access to. But I will say there is no perfect tool. There are so many types of software out there, and we all use so many different things that it's going to be pretty hard to get everybody on the same bit of software. So I don't think there's necessarily a perfect one versus the other. But I do think it matters that when you do agree on a setup that works well for the project team. Cybersecurity, you definitely want to train your team. Focus on good practice. I mean, everybody's companies should be teaching about this. I mean, they should be having discussions about this regularly. We are. Use strong passwords. I won't get into all the recommendations on cybersecurity. That's a whole other topic. Two-factor authentication, but it is a big deal when you're working in a decentralized environment. You got to maintain really good cybersecurity practices. Like I said, on file structure, you really want to determine that early and manage it well. So that whoever the project manager is should really preach it. If the project's big enough, have somebody that's just managing files and kind of saying, "Hey, no, you put this in the wrong spot. No, that doesn't go there." It calls people out. That worked well for us on the Cedar Rapids project. You got to invest in the necessary hardware. I mean, you got to be able to work as a team. There's some electrical engineering, right? When you're doing communications, your communications is going to default to the lowest common denominator. So if you got fiber communications everywhere, and you got Cat 6 Ethernet that's communicating through media converters, but you put in some kind of communication line that's old. Today it's a Cat 5. That whole system is going to operate to the bandwidth of the Cat 5, not to the rest. So it's kind of, I look at investing in the necessary hardware the same way. If you got, everybody's got the Cadillac setup, but you got one, a small person on the team that does not have that, you're going to be operating in that person's speed, not the speed of everybody else, or you're gonna leave them behind. Have a really robust QA/QC process. You should always have a good quality control process, but in a decentralized environment, you can't walk to somebody's desk down the office from you and go, "Hey, I need you to look at this, right? You know, talk to them about it. You got to really push hard on it and make sure it's really well managed from a decentralized standpoint. Um, the last thing I just want to say is, obviously be flexible with your tools. I think it's, you know, you got to be able to operate in a decentralized way, but you got to be well structured on how you do the workflow. So that kind of goes to that flexibility and flexibility dichotomy I was talking about. So that is it. Is there any questions? Hopefully I didn't. Hopefully people are still there. So it's never gonna
Yeah,
work.
we're still alive. Fantastic. That was good. It's man, I was looking at your one slide with regards to on the communications, and I was glad to see you put phone. I'm a huge advocate of just the phone, whether it's a text, because that's the only way my kids talk to me is through text.
No, I still
And
fall into that habit. I'll send some, oh, I'll just send them an email. So, no, why don't you get on the phone and call the guy and you'll get your answer now and then you'll be
yeah,
done with it. But
or you send a Teams, message, and I barely check those, and I miss them, and you don't follow through. So, extremely, valid points on all fronts. So, excellent job. And I do want to commend you. I think it's you started out with the safety moment. That tells a lot about CDG in general. Starting out with the safety moments. Obviously, that's a big part of our of industry as a
mhm.
whole. And I know oftentimes, I work for a construction company, and I'm in the office a lot. I forget about that, and then I get out in the field and just need to make sure we're reminding that. So that's a great reminder for sure.
Thank you.
Um, so thank you. Brad, were there any other questions out there with the audience?
I think we're still waiting on questions. I guess, Pat, I
Okay.
had just going back to your Red Rock work. It sounds like I'm actually involved with Red Rock and the area that I work in, the sluice gates, that
Uh-huh.
new measurement approach. Is that you're kind, it sounded like you're still evaluated whether that's going to be successful for measuring how open the sluice gate is. Um, that sounds like if that does work, that'll be a huge improvement there for the way they measure this, all 14 of the sluice gates there.
Yeah, we're hoping so. It was kind of we went back and forth with Brian and Matthew a lot because it's kind of like, well, how do the way this is installed is that there's actually this rod that goes all
Mhm.
the way up, and that's kind of how they used to measure it. Um, and it's not really easy. You can't really replace it. It just
Mm.
you know it's a difficult thing to do. And so they were looking at encoders. So we looked at doing some kind of there's a way we can measure it with like a photo eye or a laser kind of technology, and we weren't really confident that that would work too well because how do you mount something like that in
Mhm.
here? And we found this slick kind of flow meter for hydraulics that is meant for the positioning. Um, so we're hoping it'll work out well. They're just waiting on parts
Okay.
from that. Is kind of where it's at. They they gotten the wrong thing from the vendor, and so they had to go. Well, we actually need bi-directional in that, so they got that resolved. But I think they're just waiting on that. They'll put it in, let it kind of burn in for a little while, and see if it works the way they want it to. And then if it does, they'll repeat it. So
That's pretty awesome. And the point cloud thing, I was looking forward to seeing it on your screen, but it now it looks like that. So do you use a different system then for some of the daily work with the point cloud stuff? It looks like
yeah,
that
so
is
yeah,
such
it's a
a
challenge.
powerful tool.
Yeah, it's a challenge to pull it into microstation. We haven't used it for that. Unfortunately, it's got this little spinning wheel of death right now. Uh, I thought that might happen if I went into a 360 photo, but um, if I go to this guy, I'll just make this as big as I can. Um, what this is pulling up here is a zoomed in version of this area down
Okay.
here, right?
Yeah.
And
Yeah,
so
that's awesome.
it's hard to tell, but see these little bubbles here. So these little bubbles, you'll see these sprinkled all around in the software. You can double click on them and
Mm.
zoom in, and you kind of look around. So it works a lot better when you're on our server, and it's.
Mhm.
I think what's happening is the photos still reside on our server, so it's trying to access the photos through the server over the
Okay.
internet rather than
Yeah.
just directly on the system. But
Got
um,
it.
No, it is
Yeah.
it is incredibly helpful from a design standpoint because inevitably when we go do field work, especially as an electrical, we got to open up stuff and get kind of real world conditions inside the panels and stuff. But when we go out there, you forget something. Red Rock is about a 5 hour drive, I think, from St. Louis. So
Mhm.
if we forget something, it's like, oh, crud. All right, that's like 2 days just to get some info. Now, usually we can call down there and ask them for some help if we really have to, but we hate to inconvenience maintenance guys for that kind of stuff. So um, it's just really good to kind of remind yourself where everything's at. And these photos are all by location, right? So you can kind of, all right, well, where you can go into here, this panel's here, you can go look around, you can remember where you're at in the stairwell and everything. So I was really hoping I could bring that up and show everybody, but I'm sorry it goofed up. At least I got screenshots, I guess. So
No, but that perspective alone, that's pretty awesome. Yeah, I guess that's it, Dad. I don't see any other questions, so I'll turn it back over to you. Thanks a lot, Pat, for all your work on the project.
oh, you're welcome. Thank you for the time.
Great job, Pat. And we do appreciate, we heard you volunteer for cybersecurity on the next general contract for
Yeah,
next year. So we got you locked down. We appreciate that.
there you go.
But no,
Yeah.
thank you for your time. Excellent presentation. Thank you everybody for joining in on the call. Our next presentation will be at 4 o'clock. That seems like a ways away from 7:30, doesn't it, Brad?
Yeah.
So, but it's been a great session. Really appreciate everybody joining in and excellent topics. So thanks, Pat.
Thank you.
Have a great weekend.
Thank you too.